Having seen the motivation for why mathematics in the study of computer science and the modules that we will be discussing as part of the course MFCS, Mathematical Foundations of Computer Science, let's get into the details of the first module. As mentioned, we shall be discussing this formal language, namely logic, using which we talk about how to express statements, how to prove the validity of the argument, and what impact the logic creates in the field of computer science, the importance of logic, and the formal representation of an argument or a statement. How does it help in proving the argument? How does it help in expressing statements which is free from ambiguity, brings precision? All that we shall see. Consider this argument, consider a logical argument. When we talk about logical argument, you get to see not just in mathematics or computer science, in an argument between two parties, for example, the one that happens in a court of law, you see there is a logic in it. When there is an argument between two professionals, you see there is a logic in it. So we appreciate the argument, or we associate whether the logical argument makes sense or not because of the presence of logic. So logic plays a crucial role. So look at this argument. So all prime numbers, say n greater than or equal to 3, we say are odd numbers. Then we say some odd numbers are multiple of say 5. So given these two, we conclude this. So conclusion, therefore some prime numbers are multiple of 5. So this is given. From this we wish to conclude this. So all prime numbers n greater than or equal to 3 are odd numbers. Some odd numbers are multiple of 5. Therefore some prime numbers are multiple of 5. Okay. This argument is given to us, so we want to know, is this argument true? Okay. Like this, one can frame many arguments. So some computers Linux operating system, all Linux OS device drivers installed in it. Given these two, conclusion, therefore some computers device drivers in it. Similar to this, we wish to know, is this argument true. So what is so special about so-called logic? And we say it plays a vital role in deciding the truth value of the argument. Truth value could be true or it could be false. So this is just an example. So things like this we come across in computer science. And an argument like this can come in the context of computer networks, can come in the context of operating system, can come in the context of automata theory or algorithms and so on. So is there a way of abstracting this? As mentioned, the first thing is abstract the essence and not giving importance to computers or Linux operating system and so on. Can we extract some useful info out of this? Once the abstraction is done, then what advantage are we getting? Given any argument, can we come up with a framework to talk about the validity of the argument, whether it is true or false? That's where the abstraction is so powerful. The essence of mathematical abstraction is so nice that we don't give importance to the context or the specific application. We bring the essence out and then focus on the top level picture. So for example, if we bring the abstraction out, then we talk about something called proposition. We talk about propositional variables and we express them formally using variables, and then we try proving the argument with the help of variables. So that's precisely the idea. Now, to talk about the validity of the argument, I need to set up a framework, a mathematical framework, which we shall discuss now. We will define something called assertion. We will define something called proposition. Then we define something called propositional variables. Then we define some operations on propositional variables. And finally, we will tell you how to convert an argument like this into a sequence of propositional variables, either atomic or involving logical operators. Then, given any argument of this type, it will be represented or it will be modeled using propositional variables. Then we talk about how to prove such a logical argument through propositional variables and well-known implication identities and so on. So that's precisely the focus for another 1 or 1.5 hours. Let's define a couple of terms. The first one is assertion. What is an assertion? An assertion, it is just a statement. For example, it could mean 2 plus 4 is 6, 5 plus 11 is 15, x plus y is z. Today is Monday. MTech CSC as a course on machine learning. Chennai is the capital of Tamil Nadu. Bring a pen. What is your CGPA. Great, you have cleared gate. So an assertion is a statement. It could be a statement expressing a fact like 2 plus 4 is 6, or it could be a declarative statement like this, it could be like this, could be like this, or it could be a statement which orders something, it could be a statement that questions, it could be a statement that expresses happiness and things like that. So it could mean anything. But as part of logic, what is our ultimate objective? Ultimate objective is to model an argument and talk about the validity of the argument. So which means we need statement which is of type like this. So these statements of this type, it's called declarative statement. We are interested in such statement. This is a declarative statement, this is a declarative statement, all these are declarative statement. So something that kind of orders and questions and exclamatory, something that expresses joy or happiness, sorrow and things like that, we don't consider. So as part of this course in particular, when you talk about discrete structures and in the context of first order logic, we only talk about declarative statements. And for a declarative statement, we define something called proposition. So proposition is a declarative statement which takes the truth value true or false but not both, which means either true or false. It cannot be both. Either true or false. When you use either or, not both is not allowed. Okay? And when you use either or, you allow true, you allow false, but it cannot be a situation where both are possible. Okay? So we don't allow both. Okay? Look at this one. 2 plus 4 is 6. It's a declarative statement expressing a fact. That's the definition of declarative statement, right? It expresses some fact. Whether it is true or false is what we are interested in. Statement says 2 plus 4 is 6. It is true. And 5 plus 11 is 15. It is false. Please note there are two versions when we talk about the truth value. One, it is context independent, meaning if it is true always. It is not the case that you look at this statement on a Monday or a Tuesday it is true, or some other day if you see it, it is false. At a particular point in time it is true, at a later point in time it is false. So it should not depend on time. That's one version. If you bring time and then if you bring the context into the picture, that is the other definition. So as far as this definition is concerned, it is context independent. If it is true always. If it is false always. And it is a statement, it is taking only true, it will never take false. And it is a statement taking false, it will never take the truth value true. Therefore, this is a proposition. This is also a proposition. But look at statement like this. So suppose x is 2, y is 1 and z is 3, then it is true. Suppose x is 2 and y is 5 and z is 10, it is false. So which means it depends on the context, meaning it depends on the value of x, y, z. For some instantiation it is true, for some it is false. So you cannot conclude saying it is true always or it is true, false always. And here is a statement, declarative statement, taking the value true and false. So which means this is not a proposition. Since it depends on the context, meaning depends on what values you plug into x, y, z, since that is taken into account, there is a chance that for some instance it may take true, for some it may take false, and it is contradicting the definition. If you look at today is Monday, what we are discussing is independent of the context. So if you look at it and look at this statement on a Monday, this one is true. If you look at this statement on some other day, it is false. So on Monday it is true, on say some other day, say Tuesday, it is false. So you see that the statement is taking both, so this is not a proposition. Okay, but if you fix the time frame, meaning you look at the statement on say Monday alone, fine, then this statement takes the value true. But if you don't bring the time frame, or if you bring the time frame and saying this statement will be looked at only on a Tuesday but not on other days, then this statement takes the value false always. So if you bring such a constraint or a time frame, then you can say it is a proposition. But what we are discussing now is independent of the time frame, independent of the context. So this is not a proposition. So now, having defined this, so whether 2 plus 4 equals 6 or 5 plus 11 equals 15 or x plus y equals z, so what we are interested in is the truth value. Or the message that I am trying to convey as part of this is, we are not just interested in making statement just like this. Along with the statement, we are also interested in the truth value associated with the statement. Why? An argument is precisely a collection of statements. If you talk about truth value for each statement, indeed you can talk about truth value of an argument. So with the help of truth value of each statement in the argument, one can comment about the truth value of the underlying argument, whether it is true or false. And we are working on that direction. Let me take you to the next stage and bring propositional variables and talk about the truth value of an argument through propositional variables.